Hello everybody. I'm not gonna lie, it's pretty late, so I'm going to try and get through this as best as I can. I think me cutting up the videos into a little playlist might be easier for you guys, so then you don't have to sit through like a 30-minute video of me going through problems. So I'm going to cut up the videos just like that. And I think maybe sometime this week I'm going to take out some time to go over the concepts for chapter 4 before you guys start chapter 5. But for today, we're going to go over the day 2 handout. We're going to be going over problems number 3, 4, 5, 7, and 12. And so with that, I think we're ready to just jump right in. So for number 2, a 20 milliliter sample of aqueous oxalic acid H2C2O4 was titrated with a 0.09113 molarity solution of potassium permanganate. See the net ionic equation below. A volume of 23.24 milliliters was required to reach the endpoint. What is the oxalic acid molarity? So what I'm going to do is I'm going to highlight what it's asking of us. The question is, what is the oxalic acid molarity? And I'm just going to kind of put a star by this molarity. I'm also going to notice that it says that 23.24 milliliters was required to reach the endpoint. For now, I think that's all I'm going to highlight in this situation. I'm going to write out my little line. And I think we're kind of set to get started for right now. So we're going to be starting with this volume right here, which is 23.24 milliliters. Milliliters of what? I'm not certain because it says a volume of this amount was required to reach the endpoint. I'm not going to label it as anything other than that. I'm just going to label it as milliliters. Now the second step, and I'm going to highlight this in red, is I am going to take the molarity of 0.09113 of the potassium permanganate solution. Now the reason I'm going to take that is because I know molarity, and I'm just going to write it over here, molarity equals moles of a substance. I'm just going to put of sub, if I'm not dyslexic, over our volume in liters. So we know that there is, and I'm going to put this in black, 0.09113 moles of KMN. Sorry, I'm going to capitalize the M. MnO4 over, and I know usually we put 1 liter here. What I'm going to do is I'm going to put 1,000 milliliters just to cancel out that milliliters, because we know that 1 liter is equal to 1,000 milliliters. I'm just going to point that up there. Now, from there, I think a lot of people would get stuck, only because in our equation, we don't see a potassium permanganate. We see permanganate, we see magnesium permanganate. We also know that we have our oxalic acid right here, but we don't see a potassium permanganate. So now what I'm gonna hold your hand while I explain this. What we're going to be doing is we're going to take a molar ratio of both of these, which I'm going to highlight them in purple, is we're going to take this one, and we're going to take this one. And the reason we're going to take those two, even though we obviously have potassium over here, is because we know from our ratio that 2 moles per manganate, there are 5 moles of our oxalic acid. And the reason we can do that is because technically we're just taking this and we're showing that it relates to the oxalic acid. We just drop the potassium because even though we know there's a titrated amount of the molarity, that potassium really isn't going to affect us because of our net ionic equation. It either reacts out, it either precipitates out, but because of this, our reaction doesn't need this potassium. From there, we know we're going to, this is going to cancel out our milliliters. We also know our moles of MnO4 are going to cancel out, and we're going to be left with our moles of oxalic acid. However, as I showed before, we want the molarity, and we are given the amount of milliliters that the sample is needed. We're given the amount of milliliters for the sample. So we've basically done this whole equation to find one we didn't find one, but I'm putting this as a placeholder because for our molarity we need moles of a substance, and I'm just going to put 1 in there, and then we need our volume in liters, which are 20 milliliters is going to be changed into liters. And so then we can kind of, use our calculator, and we should get around 0.2, how many? I'm not going to worry about sig figs right now. I'm just going to write to about there, and we need 4 significant figures. So honestly, we can get rid of this 3, and we have our capital molarity of oxalic acid, which is H2C2O4. And that should be our molarity. Again, this is a little tricky because 1, we're changing out milliliters, we're changing out moles of this substance compared to this substance. And then on top of that, we're taking this moles, this whole answer and, dividing it by 0.02 liters. But anyway, I will see you in the next video.